Hi all, let's discuss about how to delete a node from a given location of single linked list and insert the same deleted node in the beginning of the single linked list. Now we have a single linked list with the nodes 10, 20, 30 and 40. So let's say if you want to delete a node from third location which contains the node value 30. So we have to delete this node, and along with that we have to insert the deleted node at the beginning of the single linked list. So after performing these operations, so the newly framed linked list looks like this. So now 30 will become the first node of the single linked list, and then the second node will be 10, 20 and 40. Now if you can see in the old single linked list, there is a node between 20 and 40, that is 30. Now here after performing that delete and insert operation, there is no any node between 20 and 40, but the node which was there between 20 and 40 in the previous or in the old linked list, that became the first node of the single linked list. So that is what we have to perform as a part of this tutorial. Now let's see how we will be performing this operation in the pictorial representation. So this is a single linked list. We'll be considering this as input, and we'll be taking a help of three variables. The first one is previous to track the record of previous node, and the second one is current to assign the current node to it, and the third one is counter to keep the record of the location of the current node. So we'll start traversing from the first node, and once we traverse the first node, so the counter will become 1 because we are at first location, and the current references or current variable is pointing to the first node, and you can see previous is still pointing to null as there is nothing between there is nothing before the current. So as location value is not equal to the counter value, so we have to move forward. Now previous is start pointing to the first node, and current is pointing to 20. Counter value is 2, it means we are at second location, but user wants to delete the third node, so that means counter value is not equal to uh, location value. So in that case we have to keep moving. Now you can see the counter is 3, it means we found the third location, right? So because counter value is 3, and the location value is also 3 because user wants to delete the third node, and current is pointing to node which has data value 30, and previous is pointing to 20. So now we found the node which we want to delete, so let's remove the reference between 20 and 30 first. So now you can see the reference between 20 and 30 is removed, and we can't remove the reference between 30 and 40 because with the help of this uh, current variable, we will be able to reach to this node from the previous node wherever previous is pointing. So previous dot set next will be uh, current dot next. So let's do that. Now you can see previous next is pointing to the wherever current next is pointing. Current is this one and current next is this one. So now we have direct reference from 20 to 40, and we can remove the reference between 30 to 40, and now you can see uh, node 30 is no longer pointing to 40, it is pointing to null now. So it is completely removed from this list. Now this was the first step. So second step is uh, we have to insert the deleted node in the beginning of the single linked list. So let's do that. See, now node 30 is no pointing to null, it is start pointing to the first node of the single linked list. With the this reference, this 30 node will become first node of this list, and now there is no any node exist between 20 and 40, right? So to simplify this list, uh, now 30 is the first node, and then 10, 20 and 40. So here also this is the final result. So between 20 and 40 there is no any node exist. The node which was exist in the previous or in the old linked list, that become a first node of the single linked list. So this was a graphical representation discussion. Now let's get started with the backend code. So for that, I have already created a required classes. The first one is node class which contains two data member. The first one is data of integer type, which will be holding the value of current node. The second one is next of node type, which will hold the reference of next node, uh, along with uh, one R constructor, which we will be using to create a node of the linker list. The second one is second class is delete node from location and insert at beginning. So here uh, in this class we will be providing the logic to perform the delete and insert node at beginning implementation. So the third class is delete node from location and insert at beginning client. Here we will be calling these implementation logic inside this class. So basically this class will be containing a main method and taking care of calling the like business logic in this class. So now let's switch back to the business implementation class and let's get started. Now let's list down all the functionality which we want to implement in this class. So let's implement this functionality one by one. So expected parameter is head and location of to this method, and inside this class, as we discussed already, we'll be taking a help of three uh, variables. The first one is counter. We start from 1. The second one is current of node type, which will start from head, and the third one is node of previous, which will initially be null. Now here we'll be iterating linked list one by one by checking whether current dot next should not be null. All right, and another condition will be location should not be equal to counter. So if these both conditions are true, we'll be keep traversing of the linked list. So let's move the current pointer by one step forward if this condition is not true, right? But before moving, we need to preserve the link of the current node into previous. So let's do that. Previous is equal to current. Now before moving one step forward, we are preserving the reference of current into previous. Why we are doing that? Because once we found the node which we want to delete, so with the help of previous we can able to access the next of the current node, right? And then at the end we need to increase the counter by 1 on each node. All right, so once that is done, then what we will be doing, so we have previous dot next. Let's say we found the node which we want to delete. So let me show you here. Okay, let me view this again. Yeah, so this is a node, let's say, which we want to delete. Now we found the location which we want to delete. So in that case we need to remove the reference between this, and with the help of the current node, right, current pointer, we will be like assigning previous next to current next. So let's do that. Previous next is equal to current dot next, and then we will be removing the link of between this, yeah, current next between this one. Okay, so we have done this step. Now we have to remove the link between 30 to 40 by doing current dot next is equal to null, right? And then we'll be returning current. All right, so this is the implementation of the first functionality where we are deleting the node. Now we will be calling insert the deleted node at beginning. All right, So here, as a part of method parameter, we'll be passing two things. One is root of node type, another one is uh, deleted node of node type, right? So here, as a part of this parameter, we'll be passing the node which we have deleted here. So this current is the one which we have deleted, right? Now inside this, what we will be doing, it's a simple, right? So deleted node dot next, we will be assigning to root only, because root is the first node. Root is this one, right? The first node is nothing but a root. So the deleted node, which is this one, so this node reference or next of this node will be assigning to root. See this, the reference of deleted node we are assigning to root. Root is nothing but a first node of the singly linked list. So that is what we have done here, and then we'll be returning uh, deleted node, right? So this is the second implementation. Now the third one is we have to print all the elements of the list, singly linked list. So in that case, what we'll be doing, static, and then will be, sorry, public static. We won't be returning anything. It's just a printing the value of the each node inside this method itself. If it is non null, then do one thing, sys out of uh, root.data, and then on each iteration we need to move root by one step. We have done with this also. Now let's move to client program and let's try whether our implementation is working fine or not. So in that case, we will be creating a main method first. Inside this, we will be creating a node, like multiple nodes. Node 1 is equal to new node. We will be passing 10. So we'll be using the same 10, 20, 30 and 40 elements, like 4 nodes, and by passing the same elements so that we can compare the output with the like output of our program and output which we are expecting, we discussed in this pictorial implementation. Now firstly, we'll be printing this out, uh, this list. All right, so we are getting correct output 10, 20, 20, 30 and 40, right? Now let's see, let's call deletion operation first. Delete from location, we will be passing node 1 by passing the third as the location, and it will be returning node of deleted node. So we know that the third location we have node 30, so it should return 30 only. Let's print this out. Okay, so deleted node is 30. It means it is returning the expected output. With this logic, we are able to delete uh, the node at third location. Now, this deleted node, like as we have given location 3, now we have deleted that from the given list. Now this should be inserted in the beginning of the list. So what I'm saying is, as we have deleted this, like it is something like this now. Till here, our program is working. Now this deleted node should become a first node of the linked list, and it should print something like this. So let's try that as well. So now we have root is node 1 only, and the deleted node is deleted node, right? And it will be returning basically a new head because we have deleted the node, and that deleted node we have assigned it to the first node of the linked list. So it framed a new head. See, now this is a new head. This is no not a new head anymore. So we have the returned value is nothing but a reference of the new head. Let's keep this as a node and new head, right? And we'll be printing the same list again, like new list again. Copy, instead of passing new head, sorry, node 1 will be passing new head here. Let's try this out. But here, let's print this out. One more thing. New head is, let's verify whether it is returning 30 as new head or not. Like this is a list which we have created, and then we perform the delete node operation. We have deleted a node at third location, and we are able to delete the node 30. Then we have created a new head which is with 30, and after doing a insert node at beginning of the singly linked list, like then the deleted node we have inserted in the beginning, and the new list is 30, 10, 20, and 40. Again, the node which was there between 20 and 40 is become a first node of the linked list, and that node is no longer available between 20 and 40. So uh, these are the expected, and there are some edge cases like what if location is not present inside your uh, list. Let's say here the location we are passing is more than the size of the list, or the head itself is null. Like those are edge cases which we can handle. I think that is pretty easy, but this is the expectation from this program, and as it is working fine, so I think we are done with the implementation. And uh, thank you so much for watching this video, and stay tuned for another videos.